Okay, day 4 notes. Proving triangles similar. So our objective is to learn 3 ways to prove that triangles are similar. Alright, this is not last semester, this is earlier this semester. Okay, so what were the rules? We learned SSS. We learned SAS. We learned ASA. We learned AAS. And we learned HL. And congruent same size and shape. Okay? Now we will learn 3 ways to prove triangles similar. So what does it mean to be similar? Well, we talked about congruent angles and proportional sides. So how do you think we're going to do that? With a postulate. So here we have the angle-angle similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, then they are similar. So we're going to do the same way we did before. We're going to start with R, and then go to 1 hash mark, and then go to the second hash mark. We could have gone RST, but let's mix it up. So where are we going to start? Which one has no hash mark over here? L. And then we're going to 1, that's M, and then P. So those 2 are similar. Then we have the side similarity postulate. If all 3 sides of one triangle are proportional to all 3 sides of the other triangle, then they are similar. So what's the scale factor? Well, let's look at the small one. 3 to 9, 5 to 15, 7 to 21. Okay? If we're going this direction, it's times 3. If we're going this direction, it's times 1/3, or divided by 3. So it's a 1 to 3 or a 3 to 1 ratio. So you have 2 choices. If you're going small to big, it's 1 to 3. If you're going big to small, it's 3 to 1. So we have B, I, G, R, A, M, the same direction. We also have the Sideangleside similarity postulate. If an angle of one triangle is congruent to an angle of the second triangle, and the sides including the 2 angles are proportional, then the triangles are similar. So if you notice here, we have 32 here and here. We have a 2 to 1 ratio. The big one is double the small one for both. Or the small is half the big one. Either way. So the scale factor is 2 to 1 or 1 to 2. So I'm going to start at W and H, where the degrees are. And I'm going to go up the side 10, so WA. I'm going to go down up the proportional side over here, HI was him. Example, are these similar? If so, by which way? State the statement and scale factor if you can. So, we have an angle, and we have an angle here. We have, that angle is included between these two sides and between these two sides. Now we have to prove proportionality. If we go 6 to 4, it's times 4. If we're going this direction. If we're going this direction, it's 1/4. Well, what about 5 to 20? Same thing. 5 times 4 is 20. 20 divided by 4 is 1. So yes, MLN is proportional to SPR by SAS similarity postulate. Oh, I guess that was supposed to go up here. I missed the how. And what's the scale factor? 1 to 4 or 4 to 1. Okay, are they similar? If so, which way? Well, we do not have any angles. So what we need to do is see if we can prove proportionality all three sides. So let's find an easy one. 4 and 12. What's the scale factor left to right? Well, it's going to be times 3. Now, is 5.5 times 3 30? No, it's not. But 10 times 3 is 30, and 5.5 times 3 is 16.5. So even though they're drawn to look like it's just left to right, slide and get bigger, it's not. GB and AR are matching sides, corresponding sides. But BU corresponds down to AC. We have to flip it around. So it is yes by SSS similarity. Okay? But what you got to be careful about here is how we make the statement. So you got to be careful about this. I'm going to say GBU. Now let's think about it. I'm starting off at the corner between 4 and 10. That's the included angle between 4 and 10. So let's follow the lines. 10 goes with this side. 4 goes with this side. So which angle matches up with G? It's R. Now, I went from 4 to 5.5. Like that. So I need to go towards 16.5. So that means I'm going to do RAC. Now again, I could have started anywhere I wanted to, but you just got to be careful to match up the sides. And what's the scale factor? 1 to 3 or 3 to 1. Are the triangles similar? If so, which way? So we have one angle. So if this works out, we know S and L are corresponding. Okay? If we can prove it. Now, if you look carefully, 5 and 7 are the sides that make up the 58. 20 and 28 are not. We would need that 58 to be right here to prove similarity. Because remember, what are our three ways that we know right now? know SAS, we know SSS similarity, and we know angle-angle similarity. Well, we don't have two angles, so this one's out. We don't have three sides, so that one's out. So we need the angle to be included by the two sides, and in this case, it is not. So we would either need the 58 to be up here, or we would need this 28 to be over there. So the answer is no. We cannot do it. Even though we know that 5 times 4 is 20, and 7 times 4 is 28, the details we need are not in the right position. We don't have SAS on both triangles. The angle is not included. The numbers work out. 58 and 58, same. 5 times 4 is 20, 7 times 4 is 28, great. But they also have to be in the right position, and these are not. Now, we don't have to do it, but let's just say if we had U, G, L, and the 58 was here, and the 28 and the 20 were here, we'd be okay. Because then it would be ASELUG. It would work out great. But it doesn't. We don't have that, so we have to say no. Okay, are the triangles similar? If so, which way? State the similarity statement in the scale factor. Now we're going to go back and do a little bit of stuff we've already done before. Okay? We know we have equal angles there. Vertical angles. And since we have parallel lines, we can look for alternate interior angles. So we can mark these off as alternate interior angles. Because remember, you can look at it this way. Here are your parallel lines. Vertical triangles. If I have a line go through like that, this angle is equal to that angle, alternate interior. They're in between the parallel lines, and they're on opposite sides of the transversal. If I draw another line through, I have this angle equal to that angle. Well, if I just take this entire thing, whoops, not what I meant to do. Let me do it. There we go. Nope, not let me group it. There we go. Well, it won't let me group it. But if we spun this, rotated it 90 degrees, we'd have our drawing that we have on the board right here. So therefore, we have alternate interior angles right there also. So we actually have more than we need. We only need 2 angles, but we have 3. So we can say yes by angle similarity postulate. And then just pick where you want to go. I'm going to start E on both of them. And I'm going to go towards marker 2, which is M, up to O, emo. And the other one, I'm going to go to G, and then T. And I'm just going to go in order, 1, 2, 3, on both of them. And without any numbers, we cannot say anything about scale factor. It's not possible. So, almost done. Are the triangles similar? Well, let's look at this. What we have here is this triangle right here, A, D, E, and we have 80 degrees right there. And then we have A, B, C, and we have 80 degrees right there. Well, remember, since this bad boy came from right there, well, that's pretty good. What do we know about A? Similar to reflection property, we have that angle right there. So A and D correspond with A and B. A corresponds to itself. So we have a yes, and we have angle, angle, similarity. Now let's be careful with our naming it. I'm going to start A on both of them. I'm going to go towards the 80. So that's D, and that's B, and then just finish it up. ADE, ABC. And without any numbers for the sides, we cannot do anything with the scale factor. So, are they similar? If so, which way? Same thing we've been doing. The measures of the sides of a triangle ABC are 4, 5, and 7. A, B, C. 4, 5, and 7. I have another triangle, X, Y, Z. X, Y, Z. 16, 20, and 28. Now, if you notice, before we go any further, do we have any angles marked? No, we do not. 4 times 4 is 16. 5 times 4 is 20. 7 times 4 is 28. So we do have similar triangles by SSS similarity postulate. And then we just say A, B, C, X, Y, Z. And what's the scale factor? Like I said, it's either 1 to 4 or 4 to 1, depending on if you're going big to small or small to big. Are they similar? Well, we have our old good old friend vertical angles. Okay? If we notice, 18 is half of 36, and 12 is half of 24. So we got to think about this kind of flipping. If we could turn to one side, it would work out. So what we got to be careful is, think about is, therefore, Z does not line up with W. Z is going to line up with X. And Y is going to line up with W. Because what we really want to do is do this. And put the 24 here and the 36 here. So, are they similar? You betcha. How? By SAS similarity. We don't know what the angle is, we just know they're equal. So, I'm going to start at V on both of them. I'm going to go towards Z, which means I'm going to go towards X here, and finish up with Y, finish up with W. And what's the scale factor? 1 to 2 or 2 to 1. The beauty of the picture. So, let's wrap this up. Explain how the triangle similarity postulate theorems are alike and how they are different from triangle congruence postulates. For congruency, we use this symbol, and for similarity, we use this symbol. The rules we use are SSS, SAS, ASA, AAS, and HL. What we've learned today are SAS, SSS, and AA. Definition of congruent triangles are same size and shape. Similar triangles are congruent angles and proportional sides.